Hello and welcome back to Calculus 3. In your infinite wisdom, you voted to have exam next class, so there is the review for it. We are focusing on chapter 12. And we are going to again see 10 problems. If we have, 2 or so spicy problems, we might put the replacement problem on it like last time. Chapter 12. Oh, this is out of sequence over here. Hold on. Yeah. Chapter 12 is on functions of multivariables and derivatives, partial derivatives, Lagrange multipliers, so all of that kind of stuff is expected. So what is, if you're asking me to put 3 things in red, right, and then the rest that will still be there but not as important, I will start with the money-making section, which is Lagrange. So Lagrange multipliers problem will be featured on next exam, will be featured on the final, is featured on the project, is featured on your lab. Lagrange is one of the reasons why you are all in class. Number 2, obviously, tangent plane. Tangent plane is not just the tangent plane. Tangent plane is also linear approximation. So tangent plane has multiple things that attach to it, so we want to make sure we have the tangent plane. And number 3, gradient. Gradient, because the gradient is not just here with the directional derivatives and all of that stuff, the steepest ascent and descent and gradient used for the tangent plane and so on. Gradient is also used in chapter 14 for vector fields and for line integrals and so on. So gradient is very important. It's also featured for honors option in the Maxwell's equation. So gradient is another one that would be in red. And now what do we have for the rest? Guys, make sure everyone knows definition of the function. That was given. So definition of a function, not just honors, but everyone. Number 5, don't forget about the limits, especially 2 paths or so. Obviously, if you are able to plug a number in and come up with a solution, you are done. We have limits that you solve by factoring an algebra, which is, one way to deal with it, and then you have 2 paths to show that limit does not exist. Number 6, continuity. As you can see, I'm focusing more on particular lectures rather than particular concepts than entire lectures. So these are all concepts. Then we have, you have to know partial derivatives, obviously. Partial and directional derivatives. We said in class that the partial derivatives are always in the direction of x and the y. And directional derivatives are going to be in the direction of the vector u. Oh, let me write this also in blood over here. Directional derivatives, I'll just say unit vector. I am sick and tired of lost grades, and I have to stop and then write in unit vector. Chances are that I will not be giving you unit vector. That means who's responsible to come up with a unit vector before you do directional derivative? You, right? So is 1, 1 unit vector? No, right? 1, 1 has a magnitude of root 2. That's not a unit vector. So make sure that you are working this thing properly. So linear approximation is understood under tangent plane. I can just put it here, lin approximation as well, together with tangent vector. We have differentials. Tempted to say word problem over here. So we have the word problem for Lagrange. We have the word problem for this. Number 9, min-max. So min-max for number 9, because we also have a saddle point now, right? So you have to know the capital D, and then fxx, and then capital D less or larger than 0, and then whether it's min-max or a saddle point. So you have 3 different. So min-max, saddle. And that covers, oh, I forgot the chain rule. Hold on. Number 10, chain rule. And the chain rule will have 2 problems. Something with not that many variables, so that we can have quick calculation, and then something that you just do the tree. So 2 problems. I'll just put tree only for number 1, and number 2, full calculation. So for full calculation, we are clearly looking for something that it's maybe 2 variable based, or something that you can do quickly. So there's the list. If you consider that you have 2 chain rule problems and all of this, partial derivatives separately from directional derivatives and so on, right? We are talking about 13 problems here. But then please remember that your gradient is the vector of partial derivatives. So do I actually need to have a separate for partial derivatives? No. Chain rule also uses partial derivatives. All of the other ones. So is there going to be partial derivative question calculate? No. It might be calculate second partial derivative or third partial derivative. Fine. But, you know, calculate just the first partial derivative where pretty much every problem assesses that? No need, right? Lagrange multipliers. We know Lagrange multipliers have some of the geometry attached. So please make sure you review the volume formulas and surface area formulas. Also for Lagrange, I mean, if you have the equation in the text given, like your project has the Douglas-Cobb equation given, you can just work with that equation. If it's some simple geometry that you guys can take care of, then take care of that geometry, and technically that's what it is. Do you have any questions, concerns? Anything that I missed that you would like to add?
Proof.
Oh, yeah, for I just remembered. Number 11. 12.1 shapes. 12.1 section. I just forgot to mention 12.1. So 12.1 has those shapes. Elliptical paraboloid or hyperbolic paraboloid or a cone. I might have a problem that is going to match that. If I have a problem, it's multiple choice question to match the shape to equation. So if there is shapes thing, which is right the end, the last page of your 12 point, you have those 6 shapes. So hyperboloid of 1 and 2 sheets, and elliptical paraboloid, ellipsoid, cone, and the last one is hyperbolic paraboloid. So those 6 shapes, if I have any of them, it will be multiple choice. If you remember the graphing question from first exam, you were supposed to wrap the helix on the y-axis, right? The lab which you handed in had the question to match two questions, the multiple choice, to match the equation to that. So I actually looked at one of the labs, and those problems were done correctly. So, I'm optimistic. But please look at the shapes and make sure you can do it. All right, any questions, concerns, anything that you would like to work on? No, the honors proofs, yes. So honors here in blue. Number 1, derive partial derivative. We know that it's exactly the same calculation like in Calculus 1. Calculus 1 regular derivatives, you just have comma age. It's done in class, it's done in a book, so you have all of that. Number 2, continuity. So everyone needs to know continuity rules 1, 2, and 3. For honors section, going deeper into the concepts of continuity with either a problem or something like that. Directional derivation. And the tangent plane derivation, that's it. All of these things are outlined in the book. For continuity, we have rules plus problems. The other 3 are spelled out word to word in the book. And I think we did 1 and 4 we did in class. I know I skipped 3, I just gave you the formula. It's done in a book in a detail. For continuity, we worked in class the continuity at the point. So you have continuity at the point, global continuity in the region, and then which functions and combinations of functions are continuous if the input is continuous. So that's that part. Good. Anything you would like to work on? Any problems that you have? Question? Yes.
I had a question about one of the quizzes.
Mm-hmm.
It was one of the questions was it was a min and a max on the quiz, and it gave us the formula, but it didn't give us something it was like subjected to, or it didn't give us a constraint. So I didn't really know how to do something without a constraint. Is that?
Wait.
I think it was yesterday or the day before.
Well, min and max problems do not have constraint. Min and max problems are 12.8.
The one with
Lagrange multiplier has the constraint.
That's what it was, yeah, Lagrange.
The constraint was.
I couldn't figure that out.
So your formula was the distance formula?
Yeah.
And then your constraint was the equation.
The distance formula with the square root, the Euclidean distance. Okay, so you had the constraint given in the text, which you didn't have was the objective function.
Yeah.
An objective function was. So guys, if you are looking for Lagrange, if you are ever looking for a distance, you have the 2D distance given as square root of x minus x1 squared plus y minus y1 square, or y2, whatever. And for 3D, distance would be square root of x minus x1 squared plus y minus y1 squared plus z minus z1 squared. So that would be your 3D distance. Yes?
With that, you can just minimize the distance squared, right? And then but when you actually do the problem,
Yeah.
then you have to do it very close.
Well, it depends on what you have given, because if you have a curve given to a point is x1, y1.
No, but I'm saying like if you're minimizing the distance, it's the same as minimizing the distance squared.
Yes.
Points, so it'll be easier to calculate.
Yeah, you don't have to do the square root. Sure. Minimizing distance is the same as minimizing distance squared. Yes. Anything else? So for Lagrange multipliers, this would be your f. This would be your f. And then g is given with whatever shape you are getting close to.
Yeah, I put that one.
Anything else? Yes.
Is there any way you could open up the quizzes just view only?
Just go to study plan.
Oh,
All of the problems that are on quizzes are in study plan. All of the homework problems are in study plan.
Okay.
In study plan, everything is open 24/7. Calc 1, 2, and 3. So just go to study plan and just hit the random questions. You'll be fine. They're all labeled by section and by type. So you'll be able to find everything quickly.
Okay.
Anything else? So tangent plane question. So the red ones are guaranteed. I mean, when I say guaranteed, I mean guaranteed. You cannot escape red questions. And then the rest, whatever falls in, falls in. All right? See you all either during office hours or on Friday.